Hello 7th graders, this is Miss White and today we're doing lesson 21, surface area. So we're going to start with our opening exercise, the surface area of a right rectangular prism. So on the provided grid, we're going to draw a net representing the surfaces of the right rectangular prism. Okay, here it is. And assume that each of the grid line represents 1 inch. Then find the surface area of the prism by finding the area of the net. By looking at our prism here, how many faces make up our net? Well, we're going to have 1, 2, 3, and then we're going to have 4 for the back one. Then we'll have 5 on the side and then 6 on the bottom. So we know that there is 6 rectangular faces. Now let's create the net that this 3-dimensional shape brings. Remember, the net is a 2-dimensional shape that can be modified into a 3-dimensional form. So when we make this 2-dimensional shape, it is going to be like we're taking the pieces of this together and laying them flat. So how to get started on this is we're going to look here first. So here I know that my base and my height for my first face that I see is going to be 3 by 6. Let's go ahead and put this first rectangle on our graph. So here I have 1, 2, 3, and then I will go up 1, 2, 3, 4, 5, 6. So there I have created my first rectangle. Now, let's create our second rectangle. Our second rectangle is going to need to be above this one. So here when I go above, I see that I have this face now. To find the dimensions of this face, I know that it is going to be 3 by 4. So now I know that the dimensions here is going to be 3, and then the height is going to be 4. So I'm going to draw 4. 1, 2, 3, 4. Great. Now I understand that my first rectangle's height is 6, and the bases are 3 for both of these rectangles. Then I'm going to draw the face that's behind this one, which is going to be the same base and height. So again, I'm going to draw a rectangle here, 1, 2, 3, 4, 5, 6, and come over 3. So I know my base is 3 here, and my height is 6. And then I'm on my last rectangle, which is going to be the face that is underneath here. So I know that the face underneath here is going to be the same one that it is on top. So I'm going to create this rectangle again. So I'm going to go up 4, 1, 2, 3, 4, and then I'm going to go over 3. Here I have a base of 3 and a height of 4. Now let's go ahead and add our 2 side faces. So here's our first face we're going to do, and then our second one is going to be on the opposite side over here. So I see that this face is 4 by 6. So when I look here, I know that I have 4 units here, and then I'm going to go out 6 units. 1, 2, 3, 4, 5, 6. There is my new rectangle. And then my other rectangle is going to be 6 as well. We go down 4. Okay. So the 4 rectangles in the center form one long rectangle that is 20 by 3. So to find the area here for just this long rectangle, I'm going to outline it in red here. We know that the area of a rectangle is going to be length times width. And so now we have area is 3 inches times 20 inches. And that's going to give us a total of 60 inches squared. All right. Now we need to find the two rectangles in this wing here. So those two rectangles we're going to be looking at is this one and this one. So now we know that, again, the area of a rectangle is length times width. So I'm going to take my new area and I'm going to have 6 inches times 4 inches equals 24 inches squared. Now let's remember that that is only for one of them. So there's one and there's two. If we have two, we want to find the overall area between the both of them. So we're going to multiply 24 by 2. So now our total is 48 inches squared. So to find the total area of the net, we're going to take our 60 inches squared from our red rectangle plus the total of our two green rectangles together, which is 48 inches squared. And in your calculator, if you type in 60 plus 148, we're going to get a total of 108 inches squared. So there is how we have found the total surface area of our three-dimensional shape. All right, now let's move to example 1 over here. So for you, this is on the next page. We're working with lateral area of a right prism. So a right rectangular prism, a right rectangular prism, and a right pentagonal prism are pictured below, and all have equal heights of h. A. Write an expression that represents the lateral area of the right triangular prism as a sum of the areas of its lateral faces. Looking at the rectangular prism here, to find the lateral area, which means we're going to be looking for the area of this face, and this face. Which now this looks a little confusing, I'm not going to lie. What we don't want to find are these two faces, the ones that I'm putting in red, because it wants the lateral area. So to write the lateral area, I'm going to first take A times H. And A times H is going to represent this face here, plus the next face, which is B times H, which is going to represent the face here. And then we have C times H, which is going to represent the face in the front, which is yellow. This is the equation that we would use to find that area. Now, as I'm recording this video on my iPad, I am realizing that it is actually picking up some more audio that is coming from a movie in another room of my house. I do apologize about that. Hopefully some of that classical music was able to help you stay more focused. All right, let's move on to B. So I'm going to kind of move this around a bit so we can still see our prisms on our other page. But for right now, you may flip over to the next page, which is 123. So here for B, it says, write an expression that represents the lateral area of the right rectangular prism as the sum of the areas of its lateral faces. So again, because we're trying to find the lateral ones, the ones we do not want to find is this one and this one. Now, the ones we do want to find, we're going to write these as an expression. So I'm going to first start off with A times H. And A times H is going to be the front face here, and I'm highlighting that in blue, plus the next face, which I'm going to have is B times H, which is going to be the first face on the side, which is in green, plus A times H, that I'm putting in yellow, and that is going to be the back face here. And then finally in red, we are going to have b times h, which is going to be this face on the side over here. So to find our lateral area, that is how we would write our equation. And then finally for C, we're going to write an expression that represents the lateral area of the pentagonal prism as the sum of the area is its lateral faces. So again, the lateral faces we do not want to include here is going to be our top one and our bottom one, which I'm doing in red. And then this time, we're going to have 5 faces. So our first face we are going to do is going to be A and H. So I'm going to have A times H, which I'm going to represent as our blue. Then I'm going to have plus B times H, which I'm going to represent in red. Then I'm going to have C times H, so plus C times H. I'm going to have that one in green, plus D times H, which I'm going to have in yellow. And then finally our last one, I am actually just going to put in black because I ran out of convenient colors here. And that is going to be plus E times H. And that side is going to be right here. Again, this is how we would find the lateral area of this prism. So let's go ahead and move on to D. So it says what value appears often in each expression and why? Well, in each prism, it has the same height, which we use as h, and so therefore each lateral face has a height of h. All right, well, I hope you were able to find some more room to write that. Let's go ahead and move down to E. So for E here, it says rewrite each expression in factored form using the distributive property and the height of each lateral face. What that means is that we need to look at all of our multiplication problems that are given to us and factor out what they have in common. So first of all, we know that all of the faces have h. So for all 3 of our expressions here, we're going to use the distributive property to factor h out. So for the rectangular prism, we see that we have h here in our equation, and so we're going to factor the h out. There's our triangle. So I'm factoring h out, and then what is left is a. Then I'm going to add h plus c, okay? Again, I do want you to realize that these are equivalent expressions, but they are in different form. Now for our rectangular prism, we're going to look at this equation up here, and we're going to factor our h's out. So when we factor our h out, I have h times a plus b plus a plus b. So now, again, these are equivalent expressions, but they are in different forms. And then finally, we're going to use our last prism, which is the pentagonal prism that has 5 sides. I'm going to do my best to draw a 5-sided shape here. Good enough. All right. So then I'm going to look here at this expression, and I'm going to factor out my h. So when I factor out my h, I'm going to have h times a plus b plus c plus d plus e. Again, these equations are equivalent to one another, but they're in different form. All right, now let's review our lesson summary. So our lesson summary says that the surface area of a right rectangular prism can be obtained by adding the areas of the lateral faces to the area of the bases. The formula for surface area of a right prism is SA equals LA plus 2, where SA represents the surface area of the prism and LA represents the area of the lateral faces, and B represents the area of one base. The lateral area LA can be obtained by multiplying the perimeter of the base of the prism times the height of the prisms. All right, that concludes our lesson for today. See you in class.